terms of the kit to bring an image on top, overlay it, and transparency levels, etc. So we are a bit juggling. Is that the right level for you guys, or you want to go more deeper?
Yeah, more deeper.
Examples.
Example.
Let's discuss a little bit more about it. I know that you all are just going to sleep, but don't worry, I'm here. Just wake you up, all of you. Okay. So just, I'm sure in a couple of minutes you all would be happy because I'm just going deep inside code.
We're not, Osman, I think that what they want to do is see exactly, they don't want to understand more in detail.
Yeah, sure.
Right? I don't know. You can show reference. Who wants to go into more details about the ATK? Who wants to see examples? More details.
More detail. More detail.
More details. Samples? Examples? Okay, well, sorry, more detailed wins. For the examples, maybe we can do this. If you can stay after 4 p.m., after the second session, then we can basically lay down the applications here. You can play with them yourself. You can have the examples yourself. Okay? Thank you.
Okay, my name is Usman. Okay, so let's go to deep in a little bit coding. Okay, I think most of you are from most of you knows a little bit coding, C++, Java. Okay, if you know it, so definitely it's going to be fun. Okay, let's discuss about data set. Yes.
Java.
Okay, this is the first portion of the left side. It is C.
I see.
Sorry?
No, excellent.
Oh, sorry. Okay.
No, he's checking the result. That's it.
So essentially, remember we talked about the targets, right? The targets are the things that can be tracked. They are called trackables. So you need to be able to put them indicate in your code somewhere in the sample application. Just take the sample application, and you can see how you can map the sample application to change the target.
And so the XML is having the data of the target, right? The XML file will have the data of the file of the target.
Yeah, exactly.
Right? Okay.
Not the image itself.
No, the target.
Correct.
Yeah.
The string.
Okay. Can everyone hear me? Now? Okay. Okay. This is a little bit description about the data set. Okay. Let me explain here what is data set. Okay. If you want to hide some information in image, like you take your snapshot, for example, and you just want to hide some information in it, like steganography.
Just like a masking.
Yeah, exactly. Just if you want to just wear glasses, or for the girls, if they want to just wear the scarf, means if they want to change the scarf from their image. So then let's suppose you just took a snapshot of your face, then you go to website, upload it, and then you have to definitely download it again as a data set so you can work on it. Okay, how data set look like? It's a simple C code. There are two options. One is that you can load it from SD card, and the second option you can just store it in your app. Here is a little bit detail about data set.
That's the logic to detect where it is in your app or whether it is in your SD card. This, the XML?
Yeah, exactly. The XML giving the detail of the resolution of your image and the width of the size of your image. Okay, here
we can see this is how to start and stop the camera.
Okay.
Because your application at one point will need to start the camera. So this is to show you where the code it will start to stop the camera. It's easy. It's in basically image targets.cpp in your project. Okay?
Do you have a demo application?
I'm sorry?
Demo application.
Demo.
Application.
Yes. In the
Yeah,
demo.
we'll step by.
It's just
Demo application is enough for us.
Yeah. Okay. Pixel format conversion is what I told you. You can skip on that one. Okay. This is the. These are the three.
Modeling.
So this is basically the state. The teapot is on that target. Is on target A, for example. Okay. This asset is on that target, and the way it does it is through a structure that we're going to discuss it. So this is this is the structure, right? That gives you the camera frame, the trackables, and the events, the buttons that get pressed, and that the state object that basically your application can correct.
Let's go to the examples first. Then we come back.
This is just the rendering of the camera object with the blending the virtual as real. The next one, sorry, we're just going through it because we already spoke about it.
Okay, this is the application code.
Yeah. These are you recognize the Android state, right? This is what goes into native C++. The gray is the SDK code itself. We can go on. Okay, this is the important stuff for you to understand.
Okay, there is a little structure about programming, purely programming. The one thing more than I want to just tell you, you require two languages in this case. One is the C++ and the second one is the Java. C native and the Java for the Android, and C++ for Qualcomm library. So what you have to do, just simply interaction. There is interaction between Java and C++. So you have to just call it one by one. Some work can be done by C++ code, that is Qualcomm library, and the second portion is the Java for the Android portion. Okay, this is the major structure: initialize SDK, start tracker, handle tracker, handle tracker updates, and close SDKs. Okay, this is the image tracker example of.
All of this is if you go to the documentation, it's all explained in the documentation. We don't need to get into that level of detail. The important thing to note, if you go back to one step, is that how do you do the virtual buttons? You need to indicate where are the virtual buttons. And so you need to indicate the coordinates of the rectangles, where are the virtual buttons on your target. Yeah. Okay. So this here has 4 virtual buttons. Each one is one column. They are in rectangular format and they have coordinates. This is how they get recognized in the application.
These are the coordinates starting from the uppermost left.
Yes, exactly. You are getting right direction. These are the coordinates. Top left means top left.
Then the side.
Top right. Yeah, exactly.
Okay.
It's a rectangle. These are the coordinates of.
How we can get the coordinates of the image?
Yeah.
You have to know this, because if you are drawing image,
PhDs or
yeah, it is in millimeters, so it is starting from the center of the image.
like the CSS coordinates.
Yeah, if you say you can you can understand for your understanding, means you can take it as your understanding, but it is more bit like hexagon. It's like a little bit more.
These are in millimeters, not pixels.
Yeah, this is the millimeters.
So, to your point, when you have to overlay a 3D object over a target, this is a 3D model and this is a target. If you do it with the SDK itself, by trial and error, you might get to the right point exactly where you want to go to. If you use a tool like Unity, you see the 3D object, you see the target, you just place them on top of each other. Same thing for the virtual buttons. You can tell this is a virtual button, here it is. And the kit will take advantage, will take the rest. But you cannot modify the Unity code. So you cannot, once the application is generated, it has to be, everything has to be done through Unity. If you want to do it, if you have a sophisticated application or something you already have, you want to add augmented reality, you better start with the SDK.
Is there any tutorials? Sorry, your website? Tutorial.
Tutorial, yes, the
Yeah.
tutorial is on the website.
Can we have this presentation online?
You will get the version of this presentation. I don't know if I can give you this one specifically. I need to get it vetted by San Diego, but because we did it, but we.
There are some samples of the SDK itself.
Most of it already is drawn from the tutorials. It's just a matter of trying to use it. This is how to build 3D objects and get them recognized. Essentially 3 faces. So like a box like this, and you can even get objects to rotate it around, etc. Now this is an example, and I think we're going to pretty much stop there. This is the example, this is this example, right? How do you take an application that is about putting a teapot on a bunch of stones, right? Draw a teapot on top of a stone target. This is the sample application that you saw. Replace the stone target with an object, another target, which is let's say the image of the poster of the movie that you want to show, and then point the URL to the clip of the trigger. You take the sample application, and these are the modifications that you need besides the target to get it to do, instead of showing the teapot on top of this, instead of the sample application. If you just replace this, the sample application will show you the teapot on top of it, right? Yeah. You don't want this. You don't want the teapot anymore. What you want is, you want it to show the clip. So you need to point to the URL. Yeah. This is what explain more.
Okay, the simply we just modified a code a little bit to two sides. On the Java side, the left side is the Java side, and the right side is make it C++ side. So simply just modified the code here. On the trackables, we just calling some strings from C++ code and getting it in Java and just simply displaying our function. So let's suppose, for example, I just set a marker, okay, and then just I call it from Java code to C code. Then it triggers information and it's return it's give information back to Java code. And Java code again, it's yours. Mean whatever you want to do, any activity like play music, like play video, open website, anything you want. You can just do it right.
This is essentially where you override the existing code. You override the method in the object that basically is in the sample application to do what you want. In this case, is to go to a URL, okay, with a new intent. I think we are running.
Thank you very much.
So I think we are sorry. We got to as much as possible to squeeze this thing. Sorry for not hands-on. 4 p.m. we can let you play. It's funny. You can come back.
أنا أبغى أسمع فيدباك إذا تسمح لي أقاطع سامحني. طبعا أول شيء شكرا جزيلا أرجع. الشيء الثاني أنتم the first group في السعودية not في الريجن حتى كأتكلم في الميدل إيست to see this.
Actually,
You're
this
the
is
only
the first. This is the first training.
The first run-up
in that worldwide.
من الكلام هذا يعني بيصير. You are lucky group. We are lucky to have you. ولكن أنا عندنا 2 minutes فأنا بسمع فيدباك. احنا we'll do this مو الجروب هذا خلاص الجروب اللي جاي حيجي مساكين مصيرهم زي انتهى الموضوع. اوكي. لكن next time لما نسويها فيدباك. What do you want? What did we do right? What did we do wrong? ايش اللي نبغى نسمع منه؟ طيب أنا عشان وقفتك فعندي أول واحد. تفضل.
I'd like to say thank you for your nice presentation. Because I'd like to see we established already a business based on augmented reality. And we used your SDK for 2 years ago. We also joined the Qualcomm competition in Mobile Congress 2011. Yes.
Okay.
We have developed.
لا تعال نبغاك معي. تعال.
We have developed this.
طيب ايش اللي؟
This application.
طيب خلينا ناخذها فيو عشان نطلع الناس تطلع تخش. What is your input? ايش اللي تحبه؟
I have a lot of questions.
Questions.
I have experience in your situation. Some of them already posted in your form, some of them not yet.
جميل.
But
ناخذها اوفلاين اذا تسمح لي عشان انا ابغى اسمع ايش احنا ماذا تحب انه يكون موجود في النكست سيشن؟ هل احنا سوينا you're happy? You want this again بس hands on
بس
ولا
لا لا في نقطة مش بعد
طيب hands on. Sorry.
Workshop for what?
Workshop for work. Okay. You want to give your hands to get dirty. طيب.
هاشتاجوني
ها؟
هاشتاجوه يا شباب على
Those who downloaded the SDK, anybody have a problem with setting it up? Just, but did you have any problem basically downloading, installing it, integrated into your teams? Okay. So this is something we can take off the next workshop. You can get ready, and then we can go much more deeper.
اوكي
شباب بس انا كنت ملاحظ اللي بيهتم باليونيتي حاليا الاندرويد والاي او اس مجانا حتى 8 ابريل. التول الاعداد قيمتها 3000 ريال. قبل 8 ابريل راح تكون مجانا. فاللي مهتم اندرويد اي او اس.
طيب سيدات ما سمعنا منكم فيدباك. عفوا شكرا جزيلا. في وقت ثاني تفضل. الويب سايت حقنا موجود فيه هذا نقدر الناس اذا واجهت مشاكل بليز ايميل ما في احد في السعوديه الان شكرا جزيلا. يعني for your patient for your interview على انكم تجوا. احنا ما توقعنا الاوفر ريسبونس انه كان موجود على هذا فشكرا لكم. للاسف احنا اضطرينا نقسم ال 2 hours ل 1 hour sessions كل واحد ليها عشان نقدر نستوعب اكبر عدد ممكن. الكلام اللي تكلمنا فيه اللي حضر في الساعه 11 اللي في المين هول. اليوم هنتكلم على مور ديتيلز. حتشوف الكلام اللي كان كلنا ننظر فيه يمكن في الصباح احنا وجوجل على الترندز والفيوتشر اوف موبيليتي. you will get a chance to انكم تمسكوها بعد. nevertheless احنا نعتذر. كان الفكره كلها انه كنا نبغى نسوي ورك شوب انك تمسك بيدك. you do a hands on workshop where your hands get dirty. unfortunately حنأخرها شويه يدكم ما حتتوسخ اليوم حنوسخها في يوم ثاني. اليوم fortunately we'll keep your hands clean. ولكن السيشن it's an eye opener يفتح عيونكم على وقت الاس دي كيز capabilities of doing. فانا ما ابغى اخذ وقت كثير لان احنا it's an hour. انا اوليك ذا فلور لجيل. في زميل اخر حيجي يخش يساعده كمان شويه بس احنا we're answering the technical questions اللي ما قدرنا نغطيها في السيشن الاول عشان ضيق الوقت. و I hope you enjoy it. nevertheless من دحين احنا نوعدكم بوركشوب ثاني hopefully in the near future where we could نقدر نسوي الكلام هذا اللي بتشوفوه اليوم. كل واحد فينا كل واحد فيكم يقدر يسويه بنفسه. Thank you sir.
Thank you Rihab. Thank you for joining. So since we only have 1 hour, as you have said, we will go a bit less into the technical coding aspects, the code itself, but you will get an overview about the SDK, what it does, how it does it, and what is it, how do you make it do different things, okay? So first, maybe you can tell me if you have attended the keynote session this morning at 11, yeah? You did? Who did it? Who did it? Everybody did? Who did? Many did, okay. So in the keynote we spoke about the SDKs that Quantum provides. These are on top of Android that enable you in terms of time to market, functionality and performance. This is example, Euphoria, it's augmented reality. So the agenda really is to go over explaining a bit augmented reality, the different components in augmented reality, and based on that go into the SDK and how we can see how we can change a sample application. So augmented reality really is simple. It's the ability to add information on top of a real image or a real sports, very often, they can add lines for the horses, lines for where the ball was drawn, etc. In tennis, they will show you where the ball drops, if it's in or out. In football, they will even change the advertisements that are on the side of the field to reflect advertisements that are relevant to the region where you are watching. So augmented reality is not something new. What is new is coming to the mobile environment, because it is very challenging in the mobile environment. And so the first examples of augmented reality we have seen were location-based augmented reality. Things like Wikitube, you have a screen, you have a smartphone, so you have a screen, you have a GPS, and you have a compass. The camera gives you the view, the GPS gives you your location, and the compass gives you your direction. Based on location and direction, I can go fetch from the database what are the important things or the things that are within the layer of information I'm interested in that I can see. And based on their distance from where I stand, I can put them in perspective. And essentially, once I have that information, I can just draw on top of the real image. So this is location-based augmented reality. It's very good if you have also to see things that are outside of your field of view. Very often you have kind of a radar map with dots, and you can say, oh, there is more to see there, and you can move there. Something that vision-based augmented reality will not do. On the other hand, it relies on GPS and compass. It does not recognize the scene. So from that perspective, it's limited in the fact that it needs to work indoor. It cannot work indoor, sorry. It can only work outdoor because of the GPS. And if the database is not updated, then you will not get the right information. So for example, if I'm pointing in this direction, and let's say I have a poster of this week's, or I'm outdoor, so I'm pointing to a building, suppose it's a McDonald's, right? But in my database, it says that it's a KFC because the owner just changed it to a McDonald's. If I point to it and I see what I will see KFC, I will not see McDonald's, right? So this is the kind of inconsistencies, I think. In vision-based augmented reality, the camera actually recognizes the scene and acts upon the scene itself. So the information that is overlaid according to a target that gets recognized, and it plays with that target, and we're going to see how. So in that example, you have a Cheerios box. That Cheerios box will get recognized, and the bee will be drawn as a 3D object. The bee will always be drawn in respect to the Cheerio box. If the Cheerio box is not here, the bee will not show up. If I move like this, my bee will move outside of my field of view, right? So essentially, the object that I'm drawing, the 3D object I am adding, is in relation with the object I'm recognizing. This is vision-based augmented reality. The way it works is basically the image view gets analyzed and objects get recognized. I can recognize the face of the girl, I can recognize the Cheerio box. Now, in my database, then I can compare, essentially, the objects that I recognize with what I have in my database. In that case, I recognize the Cheerio box because my application is to draw a bee on top of a Cheerio box. It's not related to the girl specifically. By doing this, I will then, at that point, lock the location of the Cheerio box. I will acquire its location. It's a target system. It acquires the location. What does this give me? It gives me two things. First thing it gives me, suppose this is my target, right? And my target is here. It gives me my position with respect to my target. If I know the position of the target, and I know the size of the target, I know my position as well. This is XYZ. Second, because I know the shape of the target, right? In this case, it's a 3D shape. It could be an image or whatever. It also gives me the position of my phone. So essentially, is my phone low, looking at the target? Is my phone on top of the target? Is my phone on the side? Am I paddling? So it gives me all of that information. This is called 6 degrees of freedom. X, Y, Z. and angle, tilt, and pitch break. I forgot the name, so basically the other 3 degrees. And what this gives me, once I have my location, is essentially I can then scan, I can render the graphics, I can blend the reality with the objects that I want to enrich the reality with, I want to augment it with, and I can render them on the screen of my phone. So this is how vision-based augmented reality works. It has to do it very fast so that basically it looks seamless to you. What makes it a wow effect is that it is really working as if, is this thing really there? This is the question you ask yourself. If you ask yourself that question, it's because it needs to be able to scan, to compare, to position, and to render. For each object, and it can recognize multiple objects at a time, it needs to do this 30 times per second. So it has a lot of performance requirements. This is why the minimum requirements that you need is an ARM v6 with an FPU, a floating point unit, right, on top of it. And it is best optimized, in our case, for the Qualcomm platform, because essentially you have a lot of calibration that needs to be done. All the Android phones that are out there have different cameras. The camera impacts the view of what you see. There are many things on the camera that will impact things called vignetting, which is basically the distortions you will have on the sides of the camera that will impact the way the object will get recognized. This will have an impact on the augmented reality in terms of how low you can go in terms of recognizing the object. You can have other aspects in the optimization of the 3D, of the OpenGL, etc., that makes it hard to really recognize object 30 frames per second. So you want it to be smooth, to be able to pan through an object and really have the good user experience. So all of these things are optimization that happens in augmented reality. They hear me? They hear me, I think. Can you guys hear me, or do I need to get that?
Yeah. Okay.
So, what kind of applications do you see augmented reality in? So, for example, you have instructional-based augmented reality, where you take a manual, and in the past we used to have to imagine these things, where you can build an atomic or molecular structure on top of it. This way you can see it in 3D. The nice thing about augmented reality, remember about when I told you you can lock the object, you basically have the position and the position of your phone. This gives you a very intuitive 3D UI. Because if I'm looking to that object and I want to zoom in, my first natural gesture is just to get closer. And this will zoom in an object that doesn't exist. This is my target. There is no object there. Right? This is what I'm drawing on top of it. It will zoom into it. I can pan around it. I can do whatever because I have these 6 degrees of freedom. Beyond this, the object is actually also rendered on my screen. So I can interact with the object in different ways. I can interact through the UI. I can interact by touching my screen itself. So I can basically rotate the atom of oxygen itself or the DNA structure or whatever. I can do all of this. And there is something else that we'll see later on, which is called a virtual button, which is like what you have on this target. You have 4 buttons at the bottom, each one representing a color. And this is one of the examples that you can download from the website. It's Ferrari. And by putting your finger on the target, not on the screen, not on the UI of the phone, just on the target, it will change the color of the car. So you're able to go as you wish around the car and zoom in, look at the fender, look at the wheel, look at whatever you want. At the same time, you can change the color without even touching the UI, just by touching the target itself. Okay? So these are called virtual buttons. We're going to go a bit into more details. Different types of application, recognizing signs. I'm in Japan, I need to find my direction. How about it tells me basically what are these things. Third type of application, I have a menu. This is my map in my favorite restaurant, right? Or I have the logo of the restaurant. In that case, it comes even more handy because it's a different language. I just point to it, and I get it to show what it is. Okay? So, sorry?
Translation is.
No, this is not translation. This is overlay. All of this is image overlay. There is no translation. It's not like Google Translate. It has nothing to do with translation.
From where did you retrieve the information?
I'm sorry?
How could you ignite this picture? From where is retrieving this information?
This, we're going to get to this. You know, this is almost next. Last example is a taxi cab. You want to know if they take credit cards. You point to it, it tells you what the credit card is. These are the areas, we're getting to your point in 2 minutes. These are the areas that today are the most successful. If you look at the applications that are deployed, and there are many of them, it's in gaming mostly. Now, media and advertising is booming, and instructional, how to build your IKEA furniture stuff, or how to use your Cisco MP phone. So these are the most elaborate set of applications that you have today. Most of the applications are in these fields. What's coming next is translating words, visual search, and navigation in discovery. Okay? Visualizing the points of interest. So this is far field versus near field. Near field is an object that is near to me that I can recognize. Far field is a building. Okay? Now, AR, these are numbers. 25% of the mobile apps will use AR by 2012, which is this year. Okay? 25%. If you look at the mobile apps that are out there, a lot of them already use augmented reality. There are a lot of revenues generated from it, mostly because of branding and advertising. These are companies that today have applications developed for work we are working with and that are developing basic augmented reality applications. And many of them are available. Why is it that they find it useful? Because they are not, their digital media budget is very small. It's about 10% of their, it's about, let me just remove these transitions that kill the presentation here. There, no transition. Okay, whatever. So basically, why is it that they are able to, they want to do AR? It's because it gets engagement from the end user. The digital media, well, even the advertisement industry has a saying. It calls it spray and pray. You spray a message, and you pray that that the audience is going to understand the message. Essentially, that's the message. In augmented reality, you're able to achieve much more engagement from the customer. So you have 91% of people who downloaded the Starbucks app, which is just to show a little guy next to the Starbucks cup. There was a Starbucks cup, and it recognizes the cup, and it shows it's a little game, right? 91% of the people who downloaded the app used it. And the app is not only about this little character playing. The little character playing is what gets people enticed to use the app, gets them engaged. The app is about Starbucks, where you can find your Starbucks, how many have Wi-Fi hotspots, and all the services around Starbucks. And it gives Starbucks information about you, which normal advertisement will never give you. Like the billboards will never tell you that you never tell the advertisers you are watching this billboard, and by the way, where you are, and what is it that you like as well, etc. So this is why they like it very much. The second thing is that it gets them revenue. This is an application that I cannot show you, but basically it is an application for women underwear. And the catalog is dressed women. But when you put the application on top of it, you get basically the woman in underwears. Okay? So this actually generated sales. There are agencies that are now building what is called AR browsers. AR browser is like a browser, but it will, by pointing at the catalog, it will allow you to build your own objects and add them to the catalog yourself, etc. So all of this is based on our SDKs. Now, in terms of the experience at the level of branding, and I'm finishing on the application so that we can go on the technical aspect. It's the point of advertising, where you're advertising, the point of sale, and the point of use. These are the three key aspects as to where you use AR in advertising. So it is very powerful. I'm just going to switch here for a second to show you something. Suppose I have an advertisement. This is an actual advertisement in a Norwegian magazine. It is a company that makes boots, right? And this is what you see in the page of the magazine. Now, if you take your phone, there, you have this Viking app here, right? And I hope I'll be able to show it to you in a nice way. But suppose I put my boots here, and I take this Viking app, and this it will be easier, and I point to it, then it is going to load. It is going to, at one point, turn on the camera. For now, it's still loading. And it will put a boot on my target. We can't see the boot, so this is what happened for the previous presentation. You can see the boot. You will be able, we'll show it to you after, but you can see there is a boot there. And by the way, I can have a whole catalog of boots. I can change my boots. Someone was telling me it's as good as wearing them. Okay? This is, the application is called Viking. It's a simple application, but it's a way, it shows you the level of brand engagement that you can get. A simple advertisement, printed advertisement in a magazine, an application that you download. You download it why? To do this, just one second. Just to do this, right? But you know what? You keep your application and it gives you updates on Viking. Viking gets a direct screen to you, right? It gets a screen directly to you. And not only it's a direct advertising screen, billboard, personalized billboard, but it will also know exactly where you are from location, what is it that you like, etc., etc. So this is the kind of application you can do. We'll go into more such application later on. Sorry, there was a question.
I just want to ask: is this example, for example,
yes,
depends on the GPS?
Works on the GPS? No, it cannot work on the GPS. It has to recognize the scene.
We can, and the examples before that, also, I think the accuracy of the GPS can detect this.
Not only that, but indoor, there is no way I can use my GPS. I'm indoor.
GPS, I think, have an error ratio.
For indoor, yes, as well, but it will not give me that level of engagement because it does not recognize it.
And I can't replace an image on by this symbol.
Correct. The indoor, the location-based augmented reality cannot do this. Location-based augmented reality just tries to provide you more information about the direction at a given location. This is what it does. So I'm just looking at my watch because I know we have 1 hour. So I want to go through a couple of more examples for you because I think this is what speaks to you most. Who has seen the Sesame demo, the Sesame video clip this morning? You guys have seen it? Maybe I'll show it again for those who haven't because there are many of you. This is another Mercedes-Benz advertisement. Okay, and again the application is available on the website. You can go on the market. It's Mercedes-Benz, right? And it will work with that target. It will not work with this target. So I'm going to put this other target on top of it, right? So the application is launching, and I press start. And what do I see? I see my camera viewfinder. There's nothing new there, right? It is done too. It is what I see here. You can even see my finger. I remove this. It recognizes this target. This is the Mercedes. Yeah? Okay? So this is how I can engage, being Mercedes, I can engage my audience further. I can now know what color of car they like, what model they like, what they are focused on in the car. All of that information I get feedback on through this application. This is how I engage them.
That's what the label.
With sorry?
The application.
Yes, works with this paper.
Yes.
It works with the target. If that was printed in a magazine, it would recognize it. If it was a poster on the wall, it would recognize it. It just needs to recognize, to see, it recognizes this target. And we're going to go now into how it works, how it gets to recognize this.
Excuse me.
Yes?
Should we download a specific application for each advertisement?
That's a very good point. Actually, today you can avoid downloading a specific application for each. It is true that the targets need to reside, the information about the target needs to reside in the application for the application to recognize them. The first version of the SDK, each phone, like this one, each application had to have the target. There was no way to update it. But very often you have repetitive applications that are repetitive. The only thing that changes is the target and the content. And in that case, you have the ability to get, like, suppose you have a newspaper, Arab News or whatever newspaper you have, right? And you always have a big picture in the front page with a big title. Now, between the time this thing gets printed and the time you read it, information might have evolved. Very often it is kind of hot information that you have on the front page, right? Suppose you point to your screen, it recognizes that image and gives you a video clip of the latest information you have there. Or it points you to the website with the latest article on that piece of information. This is how you, as Arab News, could engage your audience further. And you can add advertisements, etc. on top of it. Once you have the interest, once it works, focus on the users, the money will follow, right? So just to close with respect to what the lady was saying. So the application remains the same. It will always be an application that will recognize the target and point to a piece of information like a video, etc. And for that, it can, every day, you can program the application every day to go fetch the latest target and the latest URL pointer, the pointer for the video.
Then it works as a link.
As a?
As a link.
The image, this image, we're going to get into this. This image works as a recognized target. Think of it like a button. Like a button on your UI. You have, on your phone, you have buttons that you press, right? On the application itself. Imagine that when the camera sees this, it is as if you press the button that corresponds to this. Long range, it's more difficult because of light, shadows, and the recognition technology that is used is more robust on near field, not on far field objects. But for the long range, usually when you're long range, you're outdoor, and for that you can use location-based, or a combination of location-based without.
Is the target interactive?
Is what?
I mean, the target.
The target.
Is it interactive? I mean that, as example, in this Mercedes app, can I change the color of the car by clicking on the target itself?
Yes. This is exactly this example here. I'm going to put it here for everyone to see. So this is, if you can download the application and you can download the target from our website, the developer website. Once you run the application, what you will see when you point to it, to this target, is a Ferrari. It's a Ferrari, California. Actually, when we did it first, someone wanted to buy the car. But it's a 3D model of a Ferrari, California. Now you have at the bottom here, you have 4 buttons. These are called virtual buttons. On the target itself, this is the target, right? If you put your finger on it, it will recognize the color, it will recognize that you pressed on red, and it will change the color of the Ferrari to red. Here on blue, yellow, and black. So this is how you can interact with the target. Now, a couple of more demos quickly before we go to the more in-depth about how it works. So imagine this is your poster, or in the case of the example that the lady brought up, it's the newspaper image, right? So now I am here with an application. I'll put it like this just for the sake of using it. I'm here with an application that will essentially, where is it? Yeah. This is, Ungama is the, okay. So this is the application. So I'll put my Ferrari target here. Do you think it will recognize it? I'm going to scan it. Does it recognize it?
No.
Doesn't recognize it. So now I'm putting my DOM2 poster. And what happens? It recognizes the poster and gives me the trailer of the movie. Okay? There you go. So it goes to the example of the newspaper. Okay, enough of this. I want to show you, before we continue, I want to show you the actual demo we did at CES this year, which is basically augmented reality on 3D objects.
What's the technology relies on? Is it
Computer vision based, yes. So let me see if I can just go this way.
Excuse me.
Yes.
But I didn't answer my question because from where is it retrieving this information?
This is, we're finishing with the examples, and I promise the next thing is we go into that.
Okay.
Sorry, it's just that. Okay, so I'm just going to make it this way. Yeah, good. I'm going to raise the volume of my PC, but you don't need really the audio. Oops. You don't see anything because you're on the wrong projector. So, Sesame, who knows Sesame Street? Everybody knows Sesame Street? Okay. So Sesame Street produced a prototype playset. The playsets are real figurines, real 3D figurines. Now for kids, right? They put them on the mat to play with. And now next thing, they take their tablet and they build a world around it. The AR application will recognize the objects and will bring them to life. Will bring them to interact with each other. Will bring other objects into the scene. Okay. So, this is in terms of application, just to give you, so you keep in mind the potential of what is feasible. Now let's go back to the, gentleman's question there. Okay, so this is our SDK. It's very popular. This is the number of downloads. These are the awards. This is the press coverage. This is the type of interaction, the type of targets you can have. You can have a map, you can have posters, you can have boxes or DVDs. You can see the trailers of the DVDs just by pointing your phone. So these are called augmentable objects. Okay? Augmentable objects are of these types. They can be image targets, they can be frame markers. These are less and less used. These are just legacy. And simple 3D objects today. The frame markers are used when you want to use multiple objects at the same time, usually because they are easier to recognize. They are pretty much like a QR code, where you just have on the side a bit of information, and you can draw whatever you want inside. Okay. The virtual buttons is what we discussed, right? So instead of pointing to the yellow to see the Ferrari in yellow, on the board I see roll dice, I point to it and my dice roll, for example. So there's a lot of requirements that are needed for the SDK to fulfill in terms of vision, of performance, and flexibility. The SDK, if you downloaded it, you downloaded the Eclipse version. If you want to download something that is quick and easy, you can do it under Unity. Now, it's quick and easy under Unity, but it's not easy to modify. So if you have an application you want to build, you'll have to go through Unity to build this application. Unity is pretty much a game development environment. It's 3D, okay? It's easier to bring an object, to put it on top of a target in Unity, push a button, create it, and yes, that's it. You just want to see a flower on top of a target, you point to it, and that's it. If that's your application, use Unity. It will generate a 20 meg file, but it will do it in 5 minutes, and you're done. If what you want to do is have logic to your application, and you want to manipulate that application, you could possibly do it in Unity if you know how to use Unity well, but since you guys are Google Android developers, you can use the Eclipse environment that we provide. Now, going into the details of the question of the gentleman there before he falls asleep. So, this is what the SDK provides in terms of functionality, and this is what your application is about. Your application will use the SDK. The only reason the SDK looks bigger is because we go into more detail. But the details of the application, the sophistication, the level of complexity really resides in your application. This is where the intelligence of your application is. Your application will use the SDK. What it will do is it will essentially query state objects. It will basically look at objects, an object structure that we have that is provided through the SDK, and your application will work on these objects. If the object structure will have the target, let's say the poster it needs to recognize, it will have the events, let's say I press that button, I turn the car red, whatever it is. All of these things will be contained into the state object. The augmented reality experience will come from the processing of the SDK. But the application itself, the way it interacts with the SDK, is just through that state object. So what it will do is go fetch the information from the state object and update your application logic based on it. And then the graphics will be rendered by the SDK itself. Okay? So we're going to go into each one of these stages. I can do it verbally, or we can go in depth into each one of these. So I'll do it verbally first in case it's good enough. Otherwise, because we don't have much time, we can go more in depth later on. Camera is just to turn on and off the camera. Your application at one point will need to turn on and off the camera. Then once you have the camera captured frame, then you need to convert that format. It's let's say in YCRCB, you need to convert it into RGB565 for processing, whatever it is. This is where the pixel format conversion happens. You have a converted frame. You have the camera frame, now you have a converted frame. The core of the application will just use that converted frame to do all of the recognition of the target, the image target, of frame markers, if there are multiple frame markers on the target. The multi-image target, it's same as frame markers, but it's just having multiple targets on the same page. And the virtual buttons. Virtual buttons, again, being these things here, okay? So the same way as we can say, here is a target, I can say, here is target, and by the way, it is occluded. There is something that is hiding pieces of it. This is what the virtual button is. This is a sub-target in my target, and by the way, there is a finger, or there is something that includes it, and now I know that it means, from my event, your application will say, okay, it means draw the Ferrari event, okay? This is how it works. Bottom line, you have the tracker. Now, once the tracker engine has done this, it will have detected new objects, it will have tracked the detected objects, and it will have evaluated the virtual buttons. It will update the state object. And the camera preview frame is rendered 30 frames per second, right? So with a mix of the original converted frame with the superimposed information. If there is an object that you need to put on top of the target, it will draw it on top of it, and this will go to your screen. This is how AR works. The bottom line is all in this stage. So what we can do is talk about the target management system. How do I get the application to recognize this target or this target, right? I take an image, a JPEG. This is my target image. I upload it to a system called the Target Management Application. It's on the developer network website that we have. It's trackables. It's an item on the top called trackables, where you manage your trackables. It will tell me two things: how robust is, how easy it is to recognize this thing, and two, it will give me a signature. That signature is what I will put in my application to recognize the target. Okay, this is exactly how it works. So, to create an image target, I go to my website, I pick the type of image is it an image, is it a box, etc. I just upload it, clicking on the upload button. I get the width information because it needs some dimension information. It will automatically identify the height itself based on the width, but it needs that information. After that, I get it in my list of trackable with a number of stars. The more stars I have, the more recognizable my object is. Okay? It doesn't mean that if I have 0 star, I will not recognize my object. I might still be able to recognize my object, not under all conditions or not under best conditions. And it might also mean that if I don't have enough details in my object to allow good tracking, right? Because what allows me to really track an object is the detail that I have in my image. If what I have here is a white piece of paper, I will get 0, and this will not be recognizable because there is nothing to recognize on it. If what I have is a circle, I will have 0. And by the way, this is still not recognizable because a circle, I can turn it in any direction, it will still be a circle. So I can, if I put my object on it, it will not move. Okay? So this is the image target system. Now the target, this is the piece of code in the SDK that looks where is the target. The target can be part of the application itself or could be on the SD card. Okay? This is it. Now where is the target itself? It's identified here into the XML that goes into your project. Okay? So you have the sample application that comes with the SDK, and you just have to rename these two to change the target and make it the target that you want. So if you want to change the target of the sample application, you take a JPEG of the target you want. You put it into the system the way we just did. You check that it is good enough for you. You get the information, and you just change these two. Okay? And this way you will get your target. Now, if in your application you need to turn on the camera, this is Eclipse, right? You have image targets in CPP. This is where the camera gets turned on, and then you have camera off. That's it, right? We've covered the camera. The pixel formatter, you don't need to do anything. It does the formatting for you automatically. The tracker, it works automatically by itself. What it will do is update the state object. This is a state object structure. I have a teapot, 3D asset. I have 2 targets I can recognize. What I'm seeing in my phone is target A recognized, and for target A, you ask me to put the teapot, so I'm telling you the teapot is on the target A. That's it. How it does it is through a structure where you have the camera frame, the trackables, which are the different targets, and the events. The events, virtual button, 1 press, virtual button, 2 press, etc. Once this is done, you have the video renderer in the back that will go and basically render the frames. Mix the reality, the real frame from the camera with the augmented target that you want to do. Who will use that? Your code. Your code. Where is the state object? Again, think of it like a button. This is like a button, or it is like it's a state. It's actually, it enables a state in your application. So if you want to put a teapot, it means that you put a teapot. Now you could examples on the tutorials on the thing. Imagine I put a teapot on this, and I have a virtual button. When I press the virtual button, I can put a fire under the teapot, and I can make smoke come out of the teapot. That's the application, no more, no less. Sorry? To move? It's automatic. It's automatic. All automatic. This is part of the SDK. The image, the renderer renders that automatically. It knows how the target has moved, and it adjusts the 3D object automatically.
So it's layer abstraction.
Sorry?
It's layer abstractions. Layer abstractions.
Layer abstraction. The overlay is layered on top of the image. Sorry. Okay. Okay, so the application status itself, you know these things. This is typical unresume, unpause, undestroy. This is Android. You can recognize it. What you have in gray are the ones that correspond to the SDK. Just information FYI. You don't need that information to build an application. Now, how does an augmented reality app look like? You have a Java component. This is your Android component, and you have a native C, C++ environment. This is where the native part of this is where the SDK runs, essentially, right? So what you do is you need to initialize the SDK somewhere in your application. This is where you call qcar init. qcar init itself will basically initialize the SDK. Then you have the tracker, my native camera setup, my native tracker startup. So basically, this is where you initiate the trackers. This will call functions into C++ that are the native camera startup and the native tracker startup. So this is where how your code interacts with the SDK. Okay? So now what we have is the trackers are up, the camera is on, the field of view that you see here is it's ready to recognize something, right? Then what you have is the tracker updates. So it needs to recognize if this tracker has been recognized or not. So this is basically where you start the renderer and it renders the video background, it updates the app logic, and it renders the application assets like the teapot.